So in this video, we're going to be looking to see how we can come up with an exponential model if we're given a table of values by using our calculator. So what I want you to do is I want you to get out your calculator and power it up. And while you're doing that, let's look at this story problem. It says bald eagles were once threatened with extinction. In the 48 contiguous states, their numbers were at an all-time low of 417 in 1963. But protection programs helped them rebound. In 2007, they were removed from the list of endangered species kept by the U.S. Fish and Wildlife Services. Now let's look at part A. It says use a graphing calculator to fit an exponential model of the form f of x equals a times b to the x power to the data. Here's the key. Let x be the years after 1960. Report the values of a and b in the table on the next page to the nearest thousandth, and so on. So let's first see what we're going to do here. So on your calculators, you're going to create a table like I've already done with your x values and your y values. Now if you type in x and a whole bunch of numbers show up, that just means that you have a whole bunch of tables already open and one of them has x already defined with a set of numbers. If that happens, go to the on button and go to where it says new document. It'll say, do you want to save? And you're going to want to click no, but and then like I said, as soon as you do that, everything will be cleared out. But for this one, I obviously don't want to do that, so I'm going to leave it as it is. So take a minute right now and type in these numbers that you see in this table. The values here, again, for the y or for the year or the x values, we're not going to put in the actual year, 1963. These are the numbers after, or these are the years after 1963. So you want to put in 3 because 1963 would be 3 years later. And 1974 would be 14 years later, and so on. So put these numbers that I have in red in your X column, and the Y column, or if you want to name it breeding pairs or number of eagles or just number, or like I did just Y, put these numbers in the Y column. So pause the video so that way you can see the numbers and get them all in your calculator and hit play when you've got them all entered in and you want to see what to do next. Okay, so you should have these numbers all entered in. Make sure after typing in the 9,789, you've hit it, you've entered, put in enter. Otherwise, if the cursor is still in there and if it's flashing, it means that number hasn't been put in and the calculator might mess up. So make sure you hit enter after typing in that last digit. Okay, so now we're just going to go to menu. Oops. Or actually, we're going to go to this graphing. We want to go to the home button and go to the histogram. So we're going to make a scatter plot next. And your screen is going to look completely different from mine because all they're doing is just throwing the data on the screen. We have to organize it. So if you hit the tab button, we're going to put the numbers on our x-axis. Hit the tab button again. Put the numbers on our y-axis. So now we have this graphed into a nice little scatter plot. So you can see it looks like an exponential graph here. So I'm going to go to Menu, Analyze, Regression. And this is an exponential regression that we're doing, so we're going to show exponential. And here we have our equation. So let's go back to our notes. So your equation here would be y equals 296.177 as your initial value times 1.079 as your growth factor to the x power. Oops. And so then it says, in part C, identify the initial amount and the growth factor and explain their meanings. So the initial amount is a 296.177, so that means in 1960 there are approximately 296 pairs of breeding pairs of eagles, and the 1.079 or growth factor means that the percent has increased by about 8% or by 7.9% since the year 1960. And let's just review how to find the residual. We'll just do that for the year 2000. So we can see here from our table that the observed value is 6,471. So you always start with your observed minus the predicted value. So to get the predicted value, we put 40 in this equation for x. And when you type that in your calculator, you're going to get approximately 6,200. So we subtract those to find our residual. And so your residual would be 271. That would be the residual for the year 2000. And then you could do the same thing for the year 2005 if you wanted, where your observed would be 7,066. Put 45 in the equation, subtract them, and when you do that, you get a negative 2002, because in that one your predicted is a lot less. I'm sorry, your predicted is a lot more than what actually happened in that year. So we're actually going to stop this video with this example, with seeing how to do this on your calculator. In the next video, we're going to be looking to see how we can apply all of what we learned to half-lives.